Hello. This lecture will cover pages 47 through 49 of my lecture notes, so please print those pages out and have them in front of you as I present this lecture on describing logic circuits, part C, the AND gate. So far we've discussed the inverter, then we looked at the OR gate, and now we're going to look at gate number 3, the AND gate, on page number 47. If you look at page number 47 at the top, there's two symbols for the AND gate. Notice the straight line on the input. The output is a multiplication. So you have 2-input gate, you can have a 3-input AND, you can have a 4-input AND, you can have an 8-input AND, but we're already going to look at the 2-input AND gate. A and B, it's multiplication. You can redraw this gate in another form, the other symbol for it. They're both AND gates. Sometimes the engineer will draw it this way, sometimes the engineer will draw it that way. It depends on how it's being used in the circuit, and we'll discuss that later. Notice that how do you get to the different form? Well, the basic gate is an AND, you change it to an OR, you invert the inputs, and you invert the output. There's the other symbol. If you want to go back, the basic gate here is a OR gate, the basic gate's OR. You redraw the other form, an AND gate, you go back to the other basic gate, you go from an OR to an AND, you invert the inputs and you invert the output, which basically takes away the bubbles. So you can go from here to here or there to there. The truth table for the AND gate says that the only time you get an output of 1 is when both of the inputs are 1. A and B both have to be 1 in both cases here in order for the output to be a 1. Now, let's look at this in a little bit more detail. I drew the gate two different ways, the AND gate two different ways here. This truth table, let's see what the story is, how this symbol here tells this story. Don't memorize truth tables. A lot of instructors will have you memorize truth tables. You memorize logic symbols. That's what you memorize. These are high active inputs because there's no bubbles on them. A high here and, that's an AND gate. A high here and a high here is the only time you get a high there. That's where the story is told on that gate. And by default, these guys are all zeros. So this is the truth table to the AND gate. Now let's look at this form of the AND gate. This tells a different story when you describe it. It says a 0 here or a 0 here is the only time you get a 0 out here. A 0 here or a 0 here is the only time you get a 0 on the output. That's where the story is told to this symbol representation of the AND. And by default, that's a 1. Notice these two truth tables are equal. When the truth tables are equal in a circuit, the logic of that circuit is identical. Okay, I'd like you to take a look at page number 47 at the bottom, continuing on. There's Boolean theorems pertaining to the AND gate. You might want to stop the video for a minute, pull out page 40 again, and take a look at law number, or theorem number 1, 2, 3, 4, 10, and 12. These theorems here describe the operation of the AND gate. And you should go ahead and go through the truth table and make sure you understand each of these. Very important. Very easy, but very important. Very similar to, I'm not going to go through them individually because we did that with the OR gate, and you can see what it's basically saying. And you'll be doing this in a pre-lab for me within the next week. So, the 7408 quad 2 input package, that is the integrated circuit for an AND gate. There's 4 of them. A quad come in a package. It's called a 7408. If you take a look here, you can look in your book. I think in your book on page, somewhere in your book, page 95, I think it is. It shows you the integrated circuit. But I'm going to have you look in the specs here. I'm going to hold this up here. I'm going to have you look in your specs on page 277 and notice that here's the AND gate, and here is the truth table that goes to the AND gate, and here's the positive logic equations for the output, which I gave you in your lecture notes on page 47. So make sure you look that over and understand those Boolean theorems pertaining to the AND gate this time. And then finally, take a look at page number 40, let's see, we're on page number 48. We're still on page 48. See examples 3.4 and 3.5 on page 74 in your textbook. Make sure you understand those examples. I'm going to show you a quick application here, and we'll be finished with this video. Remember we talked about the OR gate. We looked at page 45 in your textbook. We expanded on this comparator circuit that was going to give us an alarm whenever you had a temperature above a certain point based on this set point. And this set point's variable, by the way. You just change the voltage at this point with the little power supply, and you can change when it senses when this output goes active here. And same thing with pressure down here. That's just a voltage level coming from a power supply that you set whatever you want the set point to be. So in this particular circuit, we had an OR function. We wanted an alarm output whenever we had a temperature that was greater than a particular value or a pressure that was greater than a different value. But let's say that the engineer was designing the circuit and it's a fire alarm. This is a fire alarm here. And we're going to use two different types of transducers. We're going to have a smoke transducer up here to sense smoke levels, and this is going to sense temperature down here, or heat. So we're going to use these same comparators, but we're going to get different transducers, different set points, and we're going to sense whether or not there's smoke or whether there's heat. And I don't care whether there's smoke or heat. We want an alarm. We want an alarm when both conditions are active. Let me rephrase that. In our particular design, we want to have smoke and we want to have heat. We want to have both of them, not an OR function. I was giving you an example for an OR function again. But we want to sense this as smoke and heat. When we see smoke and we see heat in our process, probably not a good idea for a house, but for some industrial application, we have to have both smoke and we have heat, and that gives us some alarm. So the way we would change this output to perform the AND function is just change this OR gate to an AND gate, and that would give us an alarm only when both of these conditions are true. And finally, page 40, let's see where we're at here. We want to go to page 49. Yep, on page 49 to finish up the lecture. The AND operation with AND gates and the OR operation with OR gates. Here's an example. This is determine the output of the AND gate for the given time signals A and B. Here's a time signal. Time goes from left to right here, and this is what we see on the input of an AND gate, A, and this is what we see on the B input of the AND gate. We want to know what the output's going to look like. Same thing with the OR gate. I want you to stop the video, fill this in, and then come back and take a look to see if you get the same result I do. Well, if you work these out beforehand, and you really should, because that's where you're going to run into problems trying to do it on your own. But the AND function says you're going to get an output whenever both. Think of the AND function. I mean, you have to think of the gate. Here, let me look at it again. It basically says a 1 here and a 1 here is the only time you get a 1 there. Or you could also think it in terms of a 0 here or a 0 here, you get a 0 out. Both of these will work. You probably should do them both ways and understand how that works here. But basically, the way we're going to do this is we're going to say a 1 here and a 1 here is the only time we get an output here. So it's going to look like this. It's going to go high. It's going to stay high to there. It's going to come down. It's going to stay low here. It's going to be high here. It's going to come over and it's going to come down. That's what your output waveform would look like. Between 12 and 13 and between 16 and 17, that's the only time both A and B are high at the same time. And if you take a look at the OR function says either one of them. Remember, look at the symbol. a high here or a high here is the only time you get a high on the output. Or you can look at the other symbol, and it'll tell a different story, but it'll give you the same result. I would encourage you to do it both ways. But if you work this one out, notice it's low here, it goes high here, stays high the whole way to there, goes low, between 14 and 15 it's low, it goes high on 15, and it's high the rest of the way out. That's what the waveform would look like in the output for an OR operation. That concludes this lecture.